So today's topic of discussion would be raising achievement in IGCSE chemistry through deeper thinking while working remotely. Okay. So a little bit about myself. Okay. I'm Raj Thaosen. It's my 21st year of teaching chemistry, both in middle school as well as high school. I have master's degree in chemistry, education, as well as in management. I'm currently the Cambridge International Coordinator and Teacher Trainer at Beacon Academy, Indonesia. As far as hobbies are concerned, I enjoy taking brisk walks and playing badminton. I have a teenage daughter named Tanisha. She's currently studying in year 8 in the same school that I'm in. And Miss Seema is my wife. Okay, she's also a junior school and middle school science teacher. A fun fact about myself, if you try to spell my name Raj, okay, from the elements in the periodic table, Ra for radium. And if you look at the periodic table, you'll find that the element J is interestingly not listed. All right, so that's something a bit peculiar about my name. Okay. Okay, coming to the objectives that we have for today's session. Okay, so we'll be looking at ways of using remote learning technology to encourage deeper thinking, particularly in the area of IGCSE 0620 chemistry. We'll be using concept cartoons. Okay, we'll also be discussing about dual coding. We'll also discuss about how to be making use of command words in IGCSE chemistry. We'll have a short discussion about project-based learning, and also how we can use innovative apps like Kami, Cognity, and PhET, which can encourage students to be using hard thinking. Okay. Okay, we'll get introduced first to the great teaching toolkit. And, this is a wonderful little book that was been written in partnership between Cambridge International as well as with the group called Evidence-Based Education. And in this book, okay, there is a chapter concerning activating hard thinking. Okay, so that is going to be one of the focus of my discussion with you today. So what are the elements of hard thinking? Okay, basically there are 6 of them: structuring, explaining, questioning, interacting, embedding, and activating. Okay, we'll go through them one by one. Okay, but before that, okay, I wanted to understand that we are trying to get into what is this hard thinking. So before we actually delve into that, okay, I'd like to just start off an introductory kind of an activity. Okay, so I'll just take you to that. Okay. Can you see that link which I've shared in the chat? Okay, so just click on that link And Ms. Salisa will be assigning to breakout rooms, okay? And what you have to do is the team leader, okay, out there will have to solve this pictogram along with the help of the other team members, right? So basically what it does is, okay, it will take you to a web page, okay? So on the web page, you have to click start, okay? So the team member can start, okay? And then you have to solve that puzzle, okay? And after you solve that puzzle, you will give an opportunity to decipher what that picture is about and arrive at a chemical formula, okay? So that's basically what is going to be happening, okay? So you're going to start off with that puzzle first, okay? So Salisa, have you assigned them to the breakout rooms?
Yes, they are assigned. Shall I put them all in breakout rooms now?
Yeah, you can put them in breakout rooms, yeah.
Okay.
Hi, good morning. I just wanted to apologise for being late. My computer decided to crash at an inopportune time, so I do apologise.
No worries, no worries, okay. We are assigning it to a breakout room, okay, so you can join accordingly, okay. You did not quite understand, okay. So this, after you arrived at this puzzle which you solved, okay, most of the groups I noticed were able to do it quite well, okay. So the puzzle was actually, this was a sewing machine here. So this is the fish carp, okay. So carp minus DM will give you sodium, okay. And this was hide and seek, so hide, and these are rocks that you have, so hydroxide. So the name of the compound was sodium hydroxide, okay. So is there anybody who didn't get it yet? Okay, I'm sure you got it, okay. Any questions, anybody? Okay, let's go into the next section, okay. So now let's come to our main area of pursuit in terms of how we can apply hard thinking as an important aspect of 0620 chemistry, okay, because this is something which if we just take chemistry just as a kind of a routine kind of a subject, okay, and we tend to try to pass it on to our students without much of a planning going on, okay, then it will affect their learning too. So we need to try to make it as engaging as possible for our young learners, okay. And that is why I wanted to have the focus today on hard thinking, okay. And right now we are also under the pandemic, okay? We are under the COVID-19 situation, okay. So it's important for us, to think of innovative ways by which we can make our students think actively, okay, and at the same time they should enjoy the lessons that are going on, okay. So what I wanted to dwell upon is, we need to train our students, okay, to be purposeful, okay, in terms of being prepared for hard questions, okay. Now when we're talking about questions, okay, there are different types of questions that can be asked, okay. If we just ask our students a yes and no type of question, okay, you can just imagine how dull the class can be, okay, and how at the end of the day, okay, there might not be much of any input from their sides in terms of their learning experience, okay. So in order to keep it more engaging, okay, what I would advise teachers is to keep the questions purposeful, okay. Keep it open-ended so that it need not be answered in just a yes or a no. It could be in a longer sentences, okay. Also, what happens is when we're in the classroom, okay, and we ask a question, sometimes we do not get an answer immediately, okay. So my advice is you need to wait, okay. You need to wait, give the students time to respond and give better answers, okay. So what will happen is, in that case, there'll be likelihood of more students answering, okay, and you'll be also have a better sense of satisfaction at the end of the lesson, okay. And in a class there could be not just 1 or 2 students, there could be 10 or 15 students, okay. So you need to make sure that everybody has got a time to digest what the question is about, okay. So give them some time to think before you elicit an answer from them, okay. And as you're doing that, okay, you need to be like a very good moderator. You need to probe them, okay? You need to ask them in a very purposeful manner. Like, for example, can you tell me more about that particular aspect that we're discussing? Or can you explain this concept in another way, okay? Or what did you mean by when you are talking about a particular aspect that you are discussing, okay? It's good sometimes, when students might have, heard the question in a certain way, okay? So it's good as you, as a teacher or moderator, to, rephrase your sentences, okay? Talk to them in such a way that they can make sense of what he's saying. So rephrasing is a good way in which you can, communicate the same task or the concept to the student very well, okay? And thereafter, when the student has given a deep amount of thought, okay, probe them further, okay, push on, okay, and ask them, okay, what is the evidence that they have? Okay, why did they speak about that particular aspect in that particular sense, okay? So make them think, okay, make them think, okay, that's when, they become lifelong learners, okay, in that aspect, okay, rather than, just learning it by heart or rote learning, okay, that's not going to help them in the long run. So these are the things which will make it very meaningful for them. And at the end, they know that if they do all this, okay, it's going to help them in their 0620 chemistry. So if you take a look at the current scenario, okay, COVID-19 first started in December 2019, okay, and now we are in September 2021, okay. So things have moved very fast, okay, but at the same time, okay, a lot of new technologies have also come in, okay, and some were there earlier, but what has happened now is we have started to use these tools or apps in a more sustained way, okay, and more frequently. So if you take a look at some of the tools that we have, okay, like Kami PDF, Cognity, Jamboard, PhET, and Padlet, okay. Has any of you used any of these tools before? Anybody? Have you used Kami? Anybody?
Yes.
Okay.
Yes, sir. We're having Google, right?
Yeah. How have you used it? I'm just curious to know. Did you use it for marking purpose, or did you use it for as a kind of educational tool?
Marking and teaching.
Yes, sir, both.
Okay. That's good. Okay, if you've used Kami, okay. But today I just want to focus on how we can use it as an educational tool, okay, educational tool for the purpose of hard thinking. Okay, so that's going to be my focus. Okay. So in the IGCSE chemistry classroom, okay, it's important for the student to be, be in congruence to what you're trying to talk about, the topic of discussion. So it's good to use cartoons, okay, rather than just merely lecturing or trying to put forward your points of view just in the form of a mere dialogue. Okay, so it's good to put in some concept cartoons, and these concept cartoons are something which which basically what they do is they tend to provoke the thoughts of a student. Okay, they'll intrigue a student. Okay, and it helps facilitate good thinking. Okay, because what is the purpose? We want our students to think hard. Okay, we want to give them a certain stimulus. Okay, so this is one of the ways by which you as a teacher, okay, can use your time in the classroom. Okay, and remember we are now in the virtual mode, so it's very important for us to be innovative in how we are trying to convey our thoughts to the students and making sure that they are doing some amount of thinking, okay, which can help them to understand concepts even better. Okay, so one of the concept cartoons that I want to just quickly discuss is about rusting. Okay, I've taken this topic primarily because I hope it makes discussion easy, because we are a varied group of people here in terms of you might be handling different classes. So I just thought of just taking up this simple topic of rusting. Okay, and what I would like you to now do is, okay, go into your respective breakout rooms, which Salisa is now going to set you up with. And thereafter, in that, what I would like to do is discuss, okay, amongst yourselves as to what each of these individuals is talking about, okay? For example, the first person is saying, if the nails gets wet, they will go rusty, okay? There.
Sorry to interrupt, Raj, but we cannot see the slides that you're showing.
Oh, you can't see the slides? Okay.
Yeah.
Okay. Oh, sorry, my bad. Okay. I think I had got it switched off, okay, at that time. Okay. Okay, so what I was talking about is how we can use the concept cartoons, okay, for eliciting thinking responses from our students. Okay. So here, what we are going to do now is, okay, we're going to set you up into your teams, okay, in which you'll be able to, discuss amongst yourselves, okay, amongst your team members about what the thought process is going about in each of these characters that you can see here. For example, the first character is saying, if the nails get wet, they will go rusty, okay. The second character is saying, they will not rust if they are completely underwater, okay. The third, they're saying, they will not rust if you keep them cold, okay. And the fourth, they will go rusty quickly if they touch each other's nails, okay. And what I'd like you also as a group is to think, have your own thoughts, okay, and discuss, maybe try to see whether what each participant is saying, okay, makes sense to you, or do you have anything contrary ideas, okay. So there might be different thoughts coming across, so avoid being judgmental, okay, and you can, challenge anybody, or you can consolidate the ideas that are coming up, okay. So all that you can do in the respective breakout rooms. So I'll be giving you this link here, okay. So this link, okay, will take you to a Padlet, okay. To this link that has been given, okay, and thereafter each group can record their thoughts, okay, in that respective Padlets that are there. So Salisa, you can set them up into the breakout rooms, okay.
Great, everyone will be put into breakout rooms very shortly.
Yeah. Right, we have quite a lot of comments coming up in the Padlet. So any team member wants to contribute any thoughts, okay, so just share with the other groups. Okay. Anybody can have a go. Okay. Let's start with team one. Okay.
I think my group was team one.
Yeah, please.
Is it?
Go ahead.
Yeah. So we discussed on how we would respond to each of the students, and some of the answers including was telling them why their answers might not be as accurate.
Mhm.
And once we have done that, then we introduce them about why rusting is, how does rusting happen, what are the things required for rusting to happen, and then prompt them to rethink their answers and give new answers once we've given them this new information.
Right. So yes, as you can see from what the comments have also been put, okay, just putting up this simple cartoon, okay, although it might look so trivial, but it is so stimulating in terms of generating so many ideas, okay. And you're just, a group of, 20 here, but supposing we have a class of bigger class, okay, you can just imagine the kind of interaction that can happen by, putting these thought-provoking cartoons, okay. And at the same time, it's also, I was going to some of the rooms, and some of the group members were talking about certain assumptions being made, okay, whether the iron nails were really underwater, or was it different situations wherein it could be where they're in a different country, and so on. So different scenarios come up, okay, and that leads to different ideas being generated. And that's what we want. We want students to think differently, not just the routine way. All right. And that's how when we try to bombard students with different ideas and make them come up with their own thought processes, okay, it leads to innovation, it leads to better thinking, and also in our case, what we're trying to focus on is on their learning skills in IGCSE chemistry. So the concepts become ingrained better when they go through this entire process. And also the teacher is able to, look at the misconceptions that may be there, if any. Okay, so that also tends to get eliminated. All right. So thank you everyone for participating in this activity. Okay, we'll go on to the next one, okay, because there are another 2 more that I would like to do, okay, before we wind up. Okay. Okay, are you able to see the screen?
Not yet,
What is
sir.
slides?
We can
Still on Padlet. Still
Yes,
on
the Padlet.
Oh, everybody can see now? Okay. Yeah. Okay. Okay, let's go to the next one. Okay. Now,
It's still the Padlet, Raj,
Still
not the
Padlet, still Padlet.
slides.
it's still
Padlet.
Padlet. Okay. Are you able to see now?
Yes.
Yeah.
Okay, thank you.
Yes, sir.
Okay, now I'm going to take you through one more concept, okay, which also is helpful, okay, and that is this dual coding theory, okay. So according to the dual coding theory, if the same information is properly offered to a learner, okay, in 2 different ways, it helps enable the person to grasp the concept more better, okay. For example, if you take a look at the sketch of the bicycle frame that is being drawn here, okay. So if you, for example, you are trying to teach the students, okay, about a particular diagram and you want them to know the different parts of it, okay. So in this bicycle experiment that is being done, okay, what the teacher is trying to do is trying to draw the different frames, okay, step by step, okay, rather than putting the entire cycle together, okay, and just telling that, okay, this is the wheel, this is the handlebar, and so on, which at times can, make the students feel a little bit lost, okay. So that's the advantage of dual coding theory, okay. So you do it with both the writing mode, okay, and the visual mode, as well as you're trying to show the descriptive mode, okay. So we'll take a look at one concept here for electrolysis, okay. So since we're talking about IGCSE chemistry, so one of the topics which students may find a little bit challenging could be electrolysis, okay. So in this, okay, we are trying to say that electrolysis is carried out by breaking down an ionic compound, okay, in the molten or aqueous state by the passage of electricity. So there are different components that are there, okay, as part of the electronic cell, okay. And when you talk about the diagram, for example, we can start off by drawing the battery and telling them that, yes, for an electrolysis to happen, there could be a battery, okay. We need 2 electrodes, okay. So what are the 2 electrodes? We can have an anode. So you can see that what I'm trying to do is I'm also giving a description of the apparatus, okay, rather than just putting one entire, what you call, picture of the electronic cell. I'm showing them stage by stage what are the things that constitutes the electronic cell. So it has got an anode, positive anode, and that anode is connected to the positive terminal of a battery, okay. Then in addition, we have one more electrode, which is called the cathode, okay. So this cathode is connected to the negative terminal of the battery, okay. So we have 2 electrodes, anode and the cathode, okay. Anode to the positive terminal, cathode to the negative terminal of the battery. And in addition to that, we have an electrolyte, okay. This is the solution or the substance that is being broken down by the passage of electricity, okay. So it is usually an ionic compound, or it could be a molten compound, okay, in the molten state, or it could be in the aqueous state, okay. So the main stages in the electrolysis are the electrolyte should be made in the molten state so that the ions can conduct, okay, and an electric current is passed to the cell. So this is the electric current that we have, okay, which can pass to the cell, can make it conducting, okay. Then we also have anions, okay. So anions are these negatively charged ions, okay, which go towards the anode, okay, and they get discharged out here, okay. And we also have the cations, okay. So the cations are positively charged, okay? So they go to the negative electrodes. So as you know, from physics, we also say that, opposites attract. So oppositely charged ions will go to the oppositely charged electrode, okay? So the positive ions go to the cathode, the negative ions go to the anode, okay? So this is a concept which you can use, okay, the dual coding theory, okay, to make it easier for students to understand, okay? And you could do it for many other aspects of electrochemistry. Not only electrochemistry, you could use it maybe for distillation or fractional distillations, anything of that which may require the students to be focused and maybe trying to understand, okay? So what I'd like you to do now is, okay, I'd like you to go to this application, okay, called Cami, okay? So if you're using Cami for the first time, okay, it will ask you to maybe register through the Google, through your Google user ID, okay? So I'll just give you the link, okay, in case it's not visible to you, okay? Okay, so I'm just going to share it in the chat, okay? Okay, just click on that link, Cami app, okay? Just click on that link and try to log in with the help of your Google account, okay? And when it asks you for authorization, you can just authorize the Google Drive that you have, okay? Are you able to log in?
Vô rồi. Okay.
Yep, logged in.
Okay. So you'll be able to see the apparatus which I just now discussed about regarding electrochemistry, okay? So what I'd like you to do is label it, okay? I think one of you already started labeling it. So basically you're again going to do as per your team members. You already know your teams, okay? So each team, okay, you can help the other team members to fill in that member. So the team 2 is down, okay? Team 3 is below that, okay? Team 4 and team 5, okay? So you can scroll down and you can write down the different parts of this electronic cell, okay? Okay. Then also, I like the team members, to think about the definition of electrolysis. And this is the Freire model, okay, which you can use, okay, to make the understanding of, the definition of electrolysis more clearer for the students, okay? So you can use this, okay? And you can give example of an electrolysis, also non-examples, okay? And what could be the characteristics of electrolysis, if you can just jot it down here. And then we can discuss what the other members have also shared, okay? So just do that as an exercise, okay? So your different team members, you can scroll down to the different parts of this Cami app, okay? So for using, in case some of you have not got it, you can use the text box, okay? And when you're using the text box, okay, in case you want to type it, okay, just you can type whatever you want and then you can drag it, okay? Drag it to whichever point that you're talking about, okay? So get started, okay? I think team 1 has already started off. Very good, okay? Okay, team 4 is also good going, okay?
How do we know which team we're in? Is it from our last breakout room?
Yes, from your last breakout room, yeah.
Okay, thank you.
Mr. Are we contributing on the same Kami?
Yeah, in the same Kami, okay, you have to scroll down, okay, so that you can go to your respective team members, okay?
Okay, thanks.
Yeah.
I think not all of us know which team number we're in.
Okay,
Raj, do you want me to put everyone in breakout rooms again?
yeah, sure, we can do that. Yeah.
Okay.
So Selisa will be assigning to breakout rooms, okay? We can just go ahead. Okay, so we'll take a look at we'll take a look at the SCAMI now. Okay, are all of you able to hear me? Yeah. Okay. Thanks. Now this is a great tool that you can use, okay, for your online lessons, because right now we're under the pandemic, okay, and sometimes we'll be having classes going on either through face-to-face sessions if it's a blended learning going on, or otherwise if you're having remote learning also, it's possible, okay. So this is a great tool. You can use it as a whiteboard tool, but I'm trying to show you how you can use it to get students to think and write, okay. So this is something which will be very useful for students also to contribute their thoughts and ideas, okay? And it will also make it more engaging for them, because sometimes what happens if you're teaching a topic like, say, electrochemistry, okay, and the student is only listening to what you're saying, okay, there is no kind of engagement happening. So it's important from our side to make the students think, to make the students actually do some amount of activity in front of the computer. So once they feel engaged, that's when they start to think properly, okay, and they also start to interact with you, and then they start enjoying your lessons as well, right? So this is one of the ways by which, okay, we can use technology to instill thinking and also making them confident in their subject, okay, in the long run, okay. So you can use this as one of the tools, and also the Freya model, to make certain concepts more clearer, okay. All right, let's go to the next one, okay. Okay, I'm going to share my screen once again, okay. Okay, are you able to see the screen now? Yeah. Okay, so let me go to the next, okay. We'll now look at the use of command words, okay. Command words is something which students, often tend to neglect, okay. They tend to think that it's something not necessary, but we as examiners, okay, we know that, it's this command words, if the students know it well, okay, it makes a difference between somebody getting an A and somebody getting an A star, okay. So we want us learners to be doing very well as far as, their concepts not only are ingrained, but also in terms of how they answer the question papers well, okay. So if you go to the syllabus, for example, you have the list of command words already listed out there, okay. But at the same time, okay, if we make it a point, because the students may or may not go through the syllabus in quite detail. So if we as teachers, okay, we try to inculcate them the habit of going through these command words, okay, then it'll make the entire experience of writing the examination a totally different one, okay, in which they feel more confident. And at the same time, because they have practiced it well, okay, and they've gone through the thought processes very well, okay, they'll be able to write better quality answers, okay. So we have different command words, okay, and just a short listing of it here, okay. So at the end of the day, we want them to get good examination results, okay. So we can have good exercises that we can perform, okay, like for example, learning the command word of the week, okay, or trying to, getting them organized in terms of, having the command words maybe on the study table, okay, So these are things which we can initiate from our side, okay, to make them do better. And also when they're doing past papers, if you can reinforce into them that, tips like circling the key command word, okay, then it, helps them again not to lose out on that 1 or 2 marks, okay, which they might have lost if they had not been so careful, okay. Okay, now I'm going to assign you to a Jamboard, okay, and this Jamboard activity, okay, you will have to, match the command word with the correct phrase out there, okay. Okay, I've typed it on the chat. Have you all received the link?
Yep.
Okay, so please go ahead to the Jamboard, okay. And again, you need to scroll through the different tabs, okay. So team 1, team 2, and team 3. So Salisa, can you just assign them to the different teams?
Sure.
Yeah.
You're muted.
Sorry. It's good that all of you were able to finish it in a jiffy. So you saw that this little activity, what we had, it was able to, you can enable students to, participate very actively. And rather than, just telling them this is a sheet of paper that you have, okay. But on the other hand, you tell them that, yeah, this is something which you can take it like a kind of a flip kind of a classroom activity in which you would ask them to go through it at home. And later on, when they come back, you can give them an exercise such as this, okay. It hardly takes much time, but the moment the students are doing an activity like in the Jamboard, when they're trying to solve the different pieces of the puzzle, they're able to, appreciate what the process that you're trying to make them through, trying to make them think through, okay, and trying to keep them engaged, okay. And this will ultimately help them to do better in their IGCSE 0620 question paper as well. Does anybody have any questions, anything that you're not clear about these command words? Okay. Anybody, any questions? Okay. If not, then we'll go to the next one. Okay. So I'm just going to be sharing my screen once again. Okay. Okay. Are you able to see the screen, all of you?
Yes.
Yes.
Okay. So this is the solution for that. Okay. And sometimes what happens is, although the students may have got the correct answer, okay, but it also helps if you can, enable the students to actually show them actual examples from particular topics about how these different commands words can be used. Okay, like for example, define electrolysis, what you're trying to do, and ask them to make their own mark schemes. Okay, that will help them to be more engaged. Okay, and later on, when you start this process early, okay, it helps them, if you started off at least 6 months earlier, by the time they come to the board examinations, okay, they are very confident about each and every term that is being listed as part of the command words category. Okay. Now coming to this project-based learning, okay, this is something, okay, which I find is pretty useful for students to get, engaged in terms of their thoughts, okay, and because it involves projects which they have come up with, okay. So what I do is I tell them that there is something that they need to come up with a certain project, okay, and something that can help them or the community as such, okay, that can learn from them, okay. So we need to think of innovative ways by which the learning process and enjoyment in chemistry is there. So it's not that they should be only doing examinations, but we also need to see how later on they can move on to become very good students when they join university or even, for example, if they're going to do their A levels and so on, they should feel, that the knowledge was not something very bookish. Okay, so it's good to have these projects coming up, and in as far as possible, try to keep it as engaging as possible and see if it can benefit the school community. So it could also be part of their science projects, or science learning fairs that can happen. Okay, all that is something which we can plan. Okay, now I want to show you how one of my students has utilized this concept of project-based learning, okay, in actually thinking of a project. Okay, and at the same time, she was pretty involved in it. Okay, right from the process of thinking about it, designing, getting back to me in terms of the learning and so on. Okay, so I'll just show that to you. Okay.
How certain vegetables can be used as a pH indicator to find out the pH levels for different household solutions that we often use in our day-to-day lives. First of all, my research question is, can I estimate the pH of different household products using food items in my kitchen? Before beginning my experiment, I had to construct a hypothesis. My hypothesis is that the juice of the red cabbage can be used to identify acids and alkalis in my household by the solution changing different colors similar to the way other pH indicators work. The first step in this experiment is to get our cabbage and to put it into a blender. We need to do this so that the pieces are fine and we are able to strain them away to get the pure cabbage juice later on to use as an indicator. Next up, we have to get our strainer and a separate pot to move the cabbage indicator so that we can get rid of all the excess pulp that we don't need. This should leave us with a very smooth purple liquid that we can use as our indicator. The third step would be to move this liquid into a different container so that we can easily pour it into each of the glasses that we're going to be testing later on. To do this, we're going to need a funnel and a ladle so that we can avoid any unnecessary mess. Once we have already gathered our indicator that we will be using, it is time to separate each of our substances that we will be testing. For this experiment, I used a measuring cup to precisely measure out 1/4 of a cup of each of the substances. Here, I would be using soda, mineral water, vinegar, toothpaste, bicarbonate, lime, as well as bleach. Before proceeding with the experiment, I made sure to label all of the glasses so that it would be easier to record our results. Once again, I used a measuring cup to measure 1/4 cup of the indicator to add to each glass. As we can see, many of the solutions are turning different colors, which means that they could be at different pH levels. This is the final result of all of the solutions and the colors that they have changed into. After the experiment, I took note of all of the observations that I observed so that I could easily see the changes that occurred. From this experiment, I can definitely conclude that the red cabbage juice can be used as an indicator solution to identify acids and alkali. After further research, the red cabbage has a pigment called anthocyanin in its juice, which color depends on the pH of the solution. If the substance is an acid, the solution will turn into a pink to red color, whereas if it is more towards the alkaline side, the solution would turn blue to yellow. From the results I gathered, we can see that vinegar was the strongest acid and bleach was the strongest alkali. I will be discussing how certain
Okay, so that was briefly telling you about how you can use project-based learning to elicit deep thinking, because when you're doing a project, okay, it's not just something, you can do it just overnight, okay? It has to be a definite thought process that goes on, okay? And in that sense, okay, the student takes time, goes through the concepts that have been discussed in class, okay, and then thinks about how it can be applied in their own circumstances and make it their own project. So in this, okay, the challenges that we're facing now is the pandemic time, okay? There are, resources availability. I mean, the schools being under lockdown, okay, and we don't have all these raw materials that we may be looking at. So at times we need to, guide the students in terms of what activities that they can be performing at home, and also concerning the safety levels, okay, in which they are trying to do this. So as teachers, we need to guide them in terms of doing their experiment well and also taking to successful conclusion. Okay. So this project-based learning, okay, at times, there could be failures also. Okay. So we need to tell the students not to be afraid of failures. Okay. Because it is when taking risks, okay, you come up with a lot of new things which we may not have thought of before. So it's always good to encourage students to be taking calculated risk, okay, and also not being afraid to perform, okay. When we are doing all these different activities, okay, we should always try to, guide the students by asking them thought-provoking questions. Like what I said before, open-ended questions are good, okay, allowing them to think and to discover new things as they go on to do their research, okay. Now, I already spoke to you about how Kami can be used as a deep thinking tool. Okay, there is another app that I am using. Okay, apart from Kami. So Kami, I told you, you can use it for marking purposes also. You can use it for creating discussion forums. Okay, and you can use it for students for taking notes. So it's a great app that you can have. Okay, and I would recommend that you can use it. Okay, for almost every daily class activity that you have. Okay. The other app that I'm using is called Cognity. Okay, it's a very interactive textbook. Okay, it has got lots of these 3D tools. Okay, it's got lots of diagrams, three-dimensional diagrams. It's also got a lot of question answers. Okay, and it's very good for formative assessments. Okay, for example, when you taught a particular concept and you want to check their learning. Okay, there are a lot of questions that are there, which are kind of ready for you to be testing them within a jiffy. Okay, so after you've taught a particular concept, okay, let's suppose you've taught that concept of electrolysis and you want to teach them, okay, or test them, okay, you can go to the Kami website, Cognity website, okay, and here you can see, okay, there are different assessment that you can do. Okay, you can create an assignment, okay, and you can also view them in a jiffy. Okay, you can create a question assignment, okay, and the good thing about Cognity is, okay, you can go according to the topic wise, okay, whichever topic you want to do. For example, if it's electricity and chemistry, okay, there are numerous questions that are already there, okay, that you can check out, okay. So it's all these different topics areas that you can take a look at, whether it's multiple choice or short answer types, okay. So you just need to select the type of questions that you want, okay, around 10 or 15 questions, depending upon the type of assessment that you want to do, okay. And at the same time, okay, you can get the feedback instantaneously, okay. So in Cognity, okay, one of the things that you will find is, okay, regarding the assignments, okay, there's something called statistics, okay. You can view all the statistics of the different topics that you've done, okay. So it gives you an idea about how the students have been performing, okay. You can find out their scores, okay. You can find out the areas in which, okay, they have not been doing well, or the areas in which they are doing well. So it gives you a lot of food for thought as a teacher, okay, in terms of the inputs that you can have about each and every student over a period of time. So it's a very good tool that you can use in terms of generating statistics for yourself, okay, and seeing how your students have been performing, okay. Okay, So you can do a lot of analysis for yourselves to see how the students have been performing, okay? And you can use that data for improving the student learning, okay? One more application is, for example, PhET, okay? PhET is a very useful application. For example, if I go to the PhET site, okay? Let's suppose I want to discuss with the students, okay, about something about concentration that I'm doing in stoichiometry, okay? So for example, here, I have got a drink mixture, okay? So I can choose many different substances here. So supposing I have a drink mix here, okay? And I want to find out what the concentration of this is, okay? So I can arbitrarily generate a mixture, and then I can use this gadget here to determine what is the concentration. Then I can use also, you know, adding water here through this inlet here, okay? And I can dilute the solution, so you can see the values also changing, the concentration value changing, okay? On the other hand, I can also, if I want, I can release the amount of the solution that is there, okay? I can also test it in terms of, okay, if I want to remove the solute, okay, I can do that, okay? So there are different things that I can do, okay, when using PhET simulation, okay? I can also, you know, look in terms of, you know, adding different salts, okay? So I could test it out with different salts, okay, find out the concentrations. And these are some things in which you can also provoke the students to think, okay? You can ask the students, you know, what would happen if I'm going to open this inlet, okay? And if I'm going to add water to it, what would be the students' thought process in terms of giving the answer, okay? Will the solution become more dilute or more concentrated, okay? So these are some of the ways by which you can use, you know, the simulation tools or the PhET simulation tools that are there for students to think, okay, to think and, you know, answer, and that makes it more interactive rather than, you know, just doing it only from the textbook, okay? So use these simulations, and particularly during the pandemic when we have difficulty in getting many resources. So there are a number of, you know, apps that are there in PhET itself, okay, which you can try out, okay? We can try out, for example, there are exothermic reactions, endothermic reactions, okay? So all those reactions which we may not be possible to do now because schools are closed, okay, you can do it with the help of, you know, these PhET simulations that will really be advantageous to the teaching community, particularly at this time when resources are not so easy to get, okay? So that's about PhET. So it will help all the learners to really enjoy lessons, okay? They'll feel more productive, okay? And they can also try out these PhET sessions at their own pace at home, okay? So the site name is phet.colorado.edu, okay? All right, I think I've reached the end of my session. So if there's any feedback that you'd like to give me, okay, you can just go to this site here, okay?
Raj, can I ask, have you shared these slides with us somewhere that I have missed?
Okay, sure, okay. So I'll be sharing the slides with Saliza, okay, and she'll be able to share it with you later, okay? Okay, are there any questions anybody's got? Okay. Okay, before that, okay, before we wind up, okay. So I'd like you to go to this site, okay, bit.ly 3HQ, and you can just put in your comments there. I'll give you 2 minutes to fill that up, okay. Or if you have your mobile phones, you can just scan the QR code, okay. If you want, you can write your name, okay, or you can just be anonymous, okay, no problem, okay. Did you get access to it, all of you?
Yeah.
Okay, great, okay. So just give a couple of minutes, okay? And if after that, if there's any questions that any of you have, I'll be happy to answer. Okay, time for a bit of Q&A. Okay, anybody's got any questions? Okay, anything that you're curious about?
I'm okay, thank you.
Okay, that's good. Okay. So today we looked at a number of activities. Okay, we also saw how hard thinking is something which, you know, we as educators, we need to look at it more closely, because our students are actually have a lot of capacity and potential within themselves. And it is for us to bring it out. Okay. And thinking is something which is a really essential skill. Okay. And this is something which we as educators need to help to bring it out to the best of our ability. And one of our endeavors should be, how our students can go on now from their IGCSE days to becoming excellent students when they go on to university. So that process does not happen overnight. So we have to help them out in terms of, building their confidence, okay, and building their aptitude in trying to do well in IGCSE chemistry. So I'd like to thank all of you, okay, for joining in today, okay, and making it special in terms of, your involvement, okay. And I hope it helps you, and you can use it in your classrooms, okay, particularly during the online pandemic that is happening. Okay, so we need to, be innovative in how we can make it useful for our students, and also make it useful for us, so that we have a great time, okay, with the entire learning experience. Okay. So any questions, anybody? Or otherwise we can close up. Okay. If there's none. Okay. So Lisa, thank you very much. Okay. Is there anything that, yeah?
Thank you very much to you, Raj, and to everyone for attending today. I hope you found this session really useful and interesting, like I did. Thank you very much.
Thank you, everyone. Okay. And have a nice day.
Thank you, thank
Thank
you.
you.
Have a nice day. Bye.
Thank you.
Bye bye.
Thank you.
everyone.